Hi, everyone. Welcome to the Wave Federation talk on talking about what we're doing with Wave Federation and open source. I'm Dan Peterson, product manager on the Wave APIs and the Federation open source effort. With me is Jochen Bekmann, who's the tech lead for the Federation effort, as well as JD Zamfirescu, who is the lead on the open source efforts. So today, we'll go ahead and jump at the agenda slide. Fairly straightforward agenda. I'll kick things off explaining what Web Federation is and where it's headed, and then we'll do a bit of a tag team between Jochen and JD, diving a lot deeper into the architecture, the model, the code we open sourced, and how things like Fed1 works, and we'll explain all that in a moment. So, at the very high level, for context, Google Wave is a new communication and collaboration tool, and the whole point is to help people get things done. And beyond the product, there is the rich API platform and then the Federation protocol. You may have heard us talk about this as the 3 Ps, the product platform protocol of Google Wave. And this talk is primarily about the protocol. We're also lucky to have Rob Horn from SAP and David LaPalomento from Novell here to help do some demos a little bit later. And we'll do some interesting demos that I hope you'll like. But by the end of the talk, you'll understand how Wave Federation itself works, as well as how to get up and running with Fed1, which is really how to run your own Wave service. Understand more about the code we've open sourced to date, and really just generally where things are headed with this community, some client-server work we're doing, and things of that nature. So at the high level, this protocol presents a great opportunity for communication and collaboration across the web to really get improved. So it's not just talking about making things work better in one product. The whole idea is to use common protocols and open source technology so that you can actually build a distributed network of Wave providers. Notice there is no central server in that diagram, and that's the whole point. So today, I don't know who saw the Epifio video about what is Google Wave before, but mainstream collaboration is really dominated by email. And that's all right. Clearly it works. It's very popular. But what we've often noticed is that information is ripped from its context and put into email. And then it's transferred over the wire. And that's sort of a lossy format. And it seems like, given things like broadband, HTML5, and other advances in computing, we can do better. And so that's where sort of Wave Federation enters the picture. The idea is let users use the system that works best for them, and just let sort of collaboration flourish in that way. There are clearly some pieces that are inherent to Google Wave, the product, as opposed to sort of the Wave Federation protocol, and that's fine. Part of what we're trying to do here is determine more use cases so we can draw that line of what is required and what is not required. So for one example on that, there's operational transform. So clearly having consistency between one Wave server and another Wave server, the OT algorithm needs to be the same. But I don't know who's remembering the way that Spelly and Linky work inside Google Wave, the product, but those are our agents that are just features we've decided to build for Google Wave users. But clearly, having the same spell correction is not required by all Wave providers. So these are the kinds of things that, as we get more use cases, we can figure out exactly where those lines are. Those 2 examples are fairly straightforward. There are clearly ones that are less straightforward. So the other point of Wave Federation is it's always been designed so that the Wave provider can have complete control. So there's a Wave itself is a hosted concept, and Jochen will get a lot more into this. But there's the concept of sort of local and foreign users, and this ends up boiling down to being much similar to SMTP in the sense that if you're only dealing with local users, all the data stays there. And then from the open specification perspective, we published a draft last year. We're continuing to improve it with input from the community as the use cases come up. So where we've come so far. So we, last year, published these protocols and white papers. And then also in July, we shipped Fed1. And Fed1 is the sort of naive hello world client server that then federates over to other Wave providers. And so the idea there was to just encourage people to prototype and play around with the protocol. However, we didn't yet have a port live. And so a little bit later on, I think it was around November, we opened a Federation port sort of experimentally on Wave Sandbox to really let people take their Fed1 instances. Instead of just talking to each other, they can talk to Wave Sandbox. And so they can use the Google Wave client and talk over to Fed1. So today, we're working really hard to open source more code. So we're deep in the middle of working to wrap up open sourcing nearly 100,000 lines more of code. And the point there is it actually includes a fairly significant chunk of our client. So the rich text editor, you may have heard about this in the keynote. The rich text editor is one of the more difficult pieces to build because of the cross-browser intricacies and things of that nature. And the idea will be to wrap that editor in a very, very, very simple web client, such that you can then have an open source stack from the browser all the way down to the server at the bottom, and then federate that over to Wave Sandbox. So this is definitely a work in progress, but we're just telling you, giving you the latest, basically. So to look at where we've come from a slightly different angle, the set of Wave providers that have sort of popped up, the various community projects and companies that get involved. So certainly Novell Pulse, towards the end of the year, last year, came out and started working with the Wave Federation protocol. Then there's QWave, which is a C++ client. PyGoWave actually started as a gadget development toolkit, but has turned into more of a federated provider. So it's interesting to see the evolution there. Ruby on Sales. What it comes down to is sort of like whatever language you like, there's probably a project out there you could probably play with. ARWave is actually more of a domain-specific use of the Federation protocol for augmented reality. But today, as you may have heard about at the keynote, SAP Streamwork is also getting involved with the Wave Federation protocol to let users of one system work with users on Google Wave and other systems. And then there's also Process One is working on OneWave, and all these companies are demoing in the Wave Developer Sandbox as well. So that's the high-level background. Where we're headed, there are really 3 points. Improving the specs, improving those specs such that we're able to ship the Wave protocol Federation port open on googlewave.com, and then building a production quality reference implementation. The idea is that we should keep improving on Fed 1, the code we're working to open source right now, as well as the next stage, such that you can really get out there and have a production quality reference open source implementation. And with that, I'd like to bring up Jochen to go deeper into the Federation architecture.
All right, thanks, Dan. Hi, everyone. I'll give you a brief overview of our architecture. Hopefully, some of you would have already looked at the Wave Protocol website, maybe know some of these concepts better, but bear with me, I'll try and get through this quickly. So you're familiar with the regular client view, and what you generally call a wave is basically the wave panel with sometimes private replies, if you've already ever created private replies, being inlined. Now, conceptually, waves are actually sets of wavelets, and a wavelet is basically a XML or set of XML documents that are that have separate participant lists. So you'll see here, for example, one wavelet has a separate participant list from the private reply here, and wavelets are composed entirely of operations. So the history of a wavelet consists of a series of operations, and these operations are packaged together in an envelope which we use for transmitting between servers and client and server, which we call deltas. Operations are given a version number, so deltas span a series of versions, and as part of the client-server protocol, there's a negotiation over each client state, and these version numbers allow you to determine where to apply a delta. The wavelet is the unit of access control and concurrency control. Concurrency control meaning that whenever you make a change to a wavelet, that can only happen or atomically on one wavelet. So you cannot span multiple wavelets. A delta is authored by one of the participants on that wavelet, and here I show this pictorially by having that participant in the tip of the delta. So if we have a quick look at interactions between different clients and a wave server, each wave is owned by one wave server only, and that wave server is the authority over the history of Delta applications to that wavelet. Here we have 3 web clients. What you see here in red is the 2 left web clients trying to apply deltas to a wavelet, and the wave server determines in which order they are to be applied. And the dotted line shows the acknowledgement coming back from the wave server where the clients have attempted a submission. We call them submit. And here we have an acknowledgement for that submit for the client on the left. It gets version number 1. The client in the middle gets version number 6 because there were 5 operations in that first delta that got applied. At the same time, you will see the green arrows, which are updates, which are sent to all listening clients. So the client on the far right gets the deltas simply streamed, and the ones on the left, they get the deltas that are updates that were not issued by that client. Both clients are responsible, both clients and servers are responsible for doing operational transformation. And if you want to see more of the details of how the operational transformation and concurrency control works, there's a link here at the bottom of the slide to a talk that we published last year, which will go into the nitty-gritty detail. Hopefully that'll be interesting. So next I'll give you an overview of the federated case. Here we've got 2 web clients. The ones on the left are production web clients, and the simple client on the right is the client that we will be releasing code to, hopefully today, tomorrow. And this talks to the Fed1, which is the open source wave server that we released last year. Between the 2 wave servers, we have the federation protocol, and that protocol deals with the transport of wavelets, of deltas, and that allows the whole architecture to work and to have a distributed network of wave servers that talk to each other. If you're here to find out about how you can extend wave, there's basically 5 ways in which you can extend wave. The first one you're probably quite familiar with. There's gadgets and there's robots. There were 2 talks at Google I/O this year. The first one has already happened. That was this morning. The second talk is tomorrow. Gadgets and robots are basically, the gadgets are client-side, or mostly client-side extensions. Robots are a combination of client-side and back-end. So those are separate APIs, and they don't really have to do with federation at this point. The next way you might extend Wave as it stands is the open source client can be extended. So one could take the editor and the client-server protocol, embed it in your own client, and then off you go, and hopefully we'll see some interesting ones. And I've already seen very, very different implementations for how we see Wave. So we hope that points the way of using Wave protocol as a basis for all kinds of platforms. The Fed1 server, as we've released it, has a fledgling agent API. This will hopefully eventually converge to what we have in our production servers, the robot APIs, as we call them. We've got a few agents already implemented, and this might be another way in which you can interact with Wave. The same API can be used to bolt on a gateway. So this gateway would be translating between your system, whatever your backend system is, and the Fed1 Wave server. And something similar would be to embed the entire Wave server as we've released it in your own system. And in both of these 2 cases, you want to make sure that whatever objects you're representing, usually documents, and changes to those documents map fairly cleanly to the operational transformation model. So you've got operations modifying wavelets, and that you can express whatever those objects are that you're modifying in the paradigm of waves and wavelets. Right, and with that, I'll hand over to JD.
Thanks. So we're super excited today to be announcing the open sourcing of a bunch of new components of Google Wave, mostly on the client side. We've got a rich text editor, which Dan mentioned earlier is the actual editor that we use on our client. We've got more model code. We'd previously released a sort of stripped down version of the model that we used in Fed 1, and we've expanded on that significantly, and I'll talk about that in a little bit. We have a concurrency control stack, which implements some model interfaces in such a way that their changes are propagated into the server, and also transforms operations against each other so that the client remains consistent in the face of intervening operations from the server. And finally, we have a WebSocket JSON protocol that we released a couple weeks ago and are fleshing out today, and we'll hopefully be pushing into our repository later today. So just a brief overview, the Wave model consists of several different components. There's a document model which contains several representations of an actual document. As you may know, our documents are sort of canonically represented by XML, and some of them have constraints on them, things like blips and the conversation model, if you're familiar. We also have a complete conversation model that builds on top of that. We have more wavelet and blip interfaces and implementations. We have more operations on documents and waves, operations like add participant, manipulations of blips, changing of content, that kind of thing. Also, we have a concurrency control stack. Now this, in addition to having channels that communicate with the actual Wave servers, they also have a client implementation for flow controls. This is a component that restricts the number of operations you can send. It also allows incoming operations to be transformed against outgoing operations so that everything stays in sync. And it also implements Wave interfaces to help you actually interface with our Wave server for Fed 1. And finally, the rich text editor, which I won't be talking too much about today. So just to give a little overview of the model, the main component here is a wave view, which consists of several different wavelet data instances. Each of those contains several blips. They interact with concurrency control by receiving operations that change them, and they send events back to concurrency control, which then packages them in deltas and sends them to and from the Wave server. Concurrency control has some model component, which is the part that actually does the transformations, and it sends operations through a multiplexer, through a stacklet, and a few other components before actually sending deltas down to the server. Let's move on. So just to give a little bit of an example, here's how to create a wave. So if you've got your editor hooked up to a Wave manager and concurrency control connected to a Wave server, and we've got an implementation of this that we'll be pushing out later today or tomorrow. You create a new editor by sending a create request. The Wave server replies to that create request, and the concurrency control creates a new wavelet, a new blip, a new editor from the Wave manager, and the editor then hooks up its document to the document that's generated by the concurrency control stack. And then from that point on, edits to the editor will flow through the content document and down through concurrency control, where they're buffered if necessary and transformed, and then down into the Wave server. Yes, and the Wave server itself then communicates with other Wave servers if necessary, as Jochen will tell us about.
Right. The Federation protocol, as we said, is a server-to-server protocol. It's designed as such. So some people have tried using it as a client-server protocol. I don't recommend that. That's what the client-server protocol is for. Fortunately, we'll be releasing that code, so that's good. It allows you to run your own Wave service. As I pointed out, you can even roll your own, extend the Wave technology to whatever you intend using it for, and we'll see some great demos for that later today. The protocol spec that we released last year is available at waveprotocol.org, so hopefully some of you would have had a look there. There's some white papers, some really good contributions by other developers for how the nitty-gritty of this operational transformation and federation works, so please have a look. The protocol is based on XMPP. We released it last year in July, and the operational transformation and concurrency control that we use for the federation protocol and in the server that we released and in the client that we're releasing is the same as what we have in production. And there are some interesting optimizations that we made to make it particularly suited to low latency updates. So when you see concurrent editing, things like that, we've optimized it. So there are some features which are quite interesting, like commit messages, two-phase commits, things like that, that we won't be going into too much detail today, but it's something that you might want to keep in mind. Right, so let's have a quick walkthrough through an example to give you a feel for what the protocol looks like. Again, we won't have time to do a deep dive, but I hope this will be sufficient. Here we've got one wavelet. You might be able to read here the wavelet ID is in the top here, and the wavelet ID contains a domain name, and that domain name determines which wave server owns this wavelet. So in this case, it's the Fed1 wave server on the right, and that is because it's the Initech Corp wave server. And they speak to their respective clients. So we've got on the right here the simple client, and on the left our production client. Both clients have modified the wave. So the state here is both the clients have modified the wavelet by adding a participant. They've added different participants, so Anthony here on the left and public on the right. And they submitted deltas to their respective wave servers. And the next step will be to see what happens. So the wave server on the left is proxying wave server. It's, we call it a remote wave server because it doesn't own the wavelet. The wavelet on the right here is the authoritative wavelet because it lives on the Initech Corp wave server. Therefore, what the wave server on the left does merely forwards that delta to the owning wave server. And what's interesting about the federation protocol is we've built some security features into it. So it's signed here with X509 signature by the owning or by the domain that has a client making those changes. So in this case, the cert for acmewave.com is used for signing. The federation protocol also has what we call a history hash, which is a SHA-256 rolling hash over all the deltas that went into the wavelet. So at any point, you can verify the state and the history, and that all the wave servers agree about what that history is. And it's actually also used for authentication. So if you look at the detailed protocol spec, you'll hopefully find this quite exciting, because when we first pitched this, people thought it's fantastic, because in email and many other communications, this sort of stuff was not baked in. So our security folks were really thrilled. Right, so on the right-hand side, we've got a delta that got applied. This is adding the public participant. This got immediately applied, so you can see the authoritative wave down here has that participant added. That delta is also signed, and it's forwarded to anyone, any of the wave servers that are interested. So in this case, this wave server, because there's a participant here on that wavelet that is from the acmewave domain, and it so happens I just drew some other wave server that might be listening. You might also note that the wavelet on the left here, which is the copy wavelet, has not changed because this delta has not been applied yet, and this delta is only applied by this server and not by this server, so nothing's changed on the left. Finally, the delta that came from the acmewave wave server got applied by the Initech wave server, the one on the right. It's been updated here, and the delta is echoed back to this wave server, and it also applied the previous delta, so that state is updated. And the clients all receive the updates as per the client-server protocol that I showed you earlier. And importantly, this acknowledgement, which was an acknowledgement for the submit that we saw here. So this was the submit, and this is the acknowledgement for that submit, which is forwarded by this wave server, again, acting as a proxy, and it's forwarded to that client. Right, so there's 4 basic messages in the federation protocol, two of which I explained, which are submits and updates. The 2 other important ones are history request and response, which is if a wave server receives a delta at a version that is not version 0, and it hasn't seen anything about this wavelet before, it can turn around to the hosting wave server and request the history from in a version range. To do that, it needs to furnish the history request, which is the authentication mechanism I mentioned earlier. And it will then be furnished with those deltas. They can be applied, and hopefully the wave server will be able to apply the delta that it received because it now has the full history of that wavelet. Signer information request and response is related to the signing that I mentioned earlier, where a certificate can be requested from the wave server that signed the delta. The wave server that hosts the wavelet has to keep all the certificates for the wavelet that it has authority over. And these certificates are collected when other wave servers submit deltas to it. And this is so if the other wave servers go away, anyone can still verify that those deltas were authored by the domains that they claim to be. So finally, what do we still need in the federation protocol to make it match what we have in production? Firstly, the protocol is a push protocol. We currently don't have a mechanism by which you do reliable delivery, which means if you lose updates and wavelets go dead, there's no periodic attempt to contact remote wave servers and tell them that there might be something interesting for them. So we're hoping to add that very soon. We also have federated attachments. We have a spec out there, or a white paper, which will allow you to have the attachments shared between the servers. So currently we have that obviously in the production client and the production wave server. And once we can share that over the federated protocol, we'll have full support and federation there. Groups, federated groups, we have a white paper that is part of the access control white paper on the site. We have a fairly good idea of how that's implemented, and hopefully we'll be implementing that in the coming months. And finally, federated presence. We have some designs on that, and hopefully you'll see that in the next few months as well. So for all of these forthcoming attractions, we will be trying to put specs out on the protocol Google group. That's been a very good source of discussion and input from people in the community, particularly XMPP folks who in some cases know more than us wave guys about what the ins and outs and some of the paradigms of how to do things in XMPP have. So that will be quite cool to hear back from the community on that. So more documentation on the federation protocol on the protocol side. The code lives on Google Code. There's some great contributions by some folks, Anthony Watkins, James Purser, and Bryce, that we posted on further reading, and there's other stuff on the Google group. So please have a look, and yeah, hopefully we'll be federating with you before long. Cool. And with that, JD.
Thanks. So one final thing that we're going to talk a little bit about before we do a few demos is our client-server protocol that we recently released. Now, as Jochen mentioned, the federation protocol is relatively similar to the production client-server protocol that we use. Well, this client-server protocol that we released recently is also very similar to that federation protocol. You can think of it as a little bit of a stripped-down version. Slightly less functionality is needed. So it's a protocol for receiving and submitting changes on a particular wavelet. And it uses, the one that we're releasing today, uses a WebSocket transport with JSON-encoded protobuffer style messages. And all I mean by protobuffer style messages is that they're actually just keyed by number instead of in typical JSON style, you'll use string key names. So to send an update from the client to the server, the client simply combines its outstanding operations into a protocol wavelet delta, puts that delta in a protocol submit request, and sends it to the server. The server simply replies with a protocol submit response that indicates how many of the operations it sent were applied and whether there was any error. Receiving updates is slightly more complicated. You send a protocol open request with the wave ID that you're looking for. Now remember, a wave ID consists of multiple wavelets, so you also specify a prefix for all the wavelets that you're interested in. So if you're only interested in particular wavelets, you can specify a given prefix and only get those, the ones that match. And to assist with, in the case where the connection drops, the client can also send a list of known snapshot versions. So for every wavelet ID that it already has on the client, it can send the most recent version that it's seen from the server, and then the server will respond only with changes that have happened since that point. This is to prevent the server from needing to resend a whole large amount of data. So the client then receives a protocol wavelet update, which contains snapshots for any wavelets that already exist in the wave. And then beyond that, it receives updates, deltas, for any changes to those waves subsequent, to those wavelets subsequent to the request, to the snapshot. So to do a little bit of a timeline view, you send a protocol open request, you receive a snapshot back, you receive a marker indicating the snapshots are done, and then you receive a series of deltas with changes. Okay, so now we are hoping to do a few demos. So I'll start this off with a demo of the client-server protocol that we've been working on. So if I can get this working, let's see. So over on the left, I've got Wave Sandbox, which presumably some of you at least are familiar with. Here, yes, thank you. Ta-da. So now let's see if I can get this on the left. Whee. Let's try something different. Okay. So we have a Googler in New York, Andrew Hyatt, who is a very big Emacs enthusiast. And he graciously wrote a plugin for Emacs, or an extension for Emacs, that actually receives updates live. So if this is still connected, oops. You'll see that it's a little slow. We're having some network connectivity problems, but hopefully this will actually propagate all the way through. Well, maybe not. Yeah, so it's possible that we blame the network. This was working earlier, I promise. We were also hoping to show you a demo of our simple web client, which unfortunately, despite many long hours and insane contributions by Bob Vaughter and Anthony Baxter, we cannot show you. But this is code that we will be pushing live, or by live I mean into our open source repository at waveprotocol.org very, very soon, as soon as we iron out these few last bugs, and it is very exciting. So if you are a developer and you are interested in having your own Wave client, you can use our sort of simple web client to see how to hook up the various components of the editor and the CC stack and all that together to actually get a functional setup done once we figure out how to do that as well. No, I'm just kidding. Yeah, so with that, I'll pass it on to some federation demos. Thanks.
Hoping better luck. Alrighty, so we're going to do some split screen here. This is Rob Horn, product owner on SAP Streamwork.
Hello, everyone. We're really excited about this. We're going to be showing you our new free product any of you can sign up for today for SAP Streamwork. And it's a tool to help you make decisions in your everyday work. So I'll be kind of hiding back here. And I'm going to, great, you can see me there? That's great. So we've got SAP Streamwork over here. We've got Google Wave over here. And when I create a new activity, we're not going to go too much into too much storyline, but I'm just going to create a new activity for the demo here. And that was weird. OK. So I'm going to quickly add a, are we all right over there?
Just a second.
Macintosh is new
While
to me.
they're figuring that out, I'm going to so the activity purpose, we would put in here, I would say, hey, Dan, we need to work on this together. OK. So in Streamwork, you can invite anyone into a decision activity, whether they're in your organization or not. And here I'm going to go ahead and add Dan. And he happens to be a Wave sandbox user. So instead of him coming in and working in the activity inside of Streamwork, which would be usually what would happen, he should see, hopefully, something in his Wave inbox to say, hey, there's an activity, and we want to work on it together. OK?
So I'll go ahead and open that.
Well, before he goes crazy, I'm just going to add a comment here and say, can you help me with this?
So one thing to point out there is you'll notice that that did not stream in character by character. And one other thing to point out is that previously we've talked about draft mode when we're creating blips and doing entries in Google Wave. You can sort of think about this as SAP chose to implement auto draft mode for blip creation, whereas we chose the other way for now. Clearly, draft mode is something we want to have in Google Wave, but we haven't done it yet. But this, again, shows differences that still work on the protocol.
Now, I actually happen to be logged in as Joseph. So who's the developer who made all this happen? So that's not me, but it was me. So Dan's going to comment back here. And you can see, if you can see it on my side, he actually is coming in character by character. So we're really excited about that. And so I'll just ask Dan, I say, can you go back into the blip where I say, hey, Dan, can you go and edit some of the content of that so we can start to work on this document or whatever it is that we're working on together? And you should see on my screen, sometimes it's character by character really fast, and sometimes it's, oh, there it is. Maybe a bit of a jumpy there. So we're really working together here. We've made some comments to each other back and forth. He's edited the document. You can imagine this was an important document about our partnership, but we're not going to get into that too much right now. Now, in SAP Streamwork, we provide you with a set of tools to help you get your work done. And in here, I'm going to go into the deciding category, and we happen to have a very simple tool, which we all use, pro cons on a few options. So I'm going to add that. Very much like what you would see in a widget or a gadget in Wave. And I'm just going to quickly type in option 1, enter.
And you'll see, as Rob is typing those options in, they show up on Wave Sandbox as well, using federation as well as the similar, effectively, gadget APIs.
OK. So Dan notices, hey, you forgot option 3. So he's going to go quickly add that in. Enter.
And then we can go ahead and just add cons or add pros, and they will work just fine.
OK, so I'm not a fan of option 3. Oh. I did the one thing I was not supposed to do. Okay, and you should see it come in.
Indeed.
Okay. We're just getting a little bit off here. Oh, I saw yours come in. So forgive the slowness of the updating to a little bit of network issues we're having here, but you see them coming through. And the nice thing is he's attributing that change to Joseph or me. And I can see those come through as well. So
yeah, the idea here is that while a wave is a very interesting concept, a gadget is a pretty important piece to it because text is interesting, but having things like maps or things like pro-con tables, either written by the provider or written by third-party developers, are very important. And so having a similar set of gadget APIs that still then federate across the various wave providers is quite useful.
Right, so I'm just going to add a comment here quickly and say, let's go with option 2. And we're having now a conversation about all the feedback we got, and it comes in as an indented blip. So this is a POC that we're really excited to work on that really shows that we want to enable this collaborative communication to help get work done. SAP Streamwork really focuses on a specific thing around getting decisions done and helping you have the right tools that we think need to get that done. And we build in a lot of security and different things that you'll want in the enterprise, and we can invite all those wave people in there.
Yeah, so we get some more demos up our sleeves. Thank you. This is David LaPalomento from Novell.
Yes, hi, I am David LaPalomento. I am a lead developer for the front end of Novell Pulse, which maybe you've heard about, but it's a next generation social messaging product that we're developing at Novell right now. And basically, one of the primary goals of Novell Pulse when we got started was to let you instantly communicate with people anywhere, whether they're your friends or people on your team at work, in a different business unit, or in another corporation or organization. So it was a natural fit to adopt the Wave protocol and allow us not only to do that sort of real-time collaboration with other Pulse users, but also do that with other Wave protocol providers like wave.google.com or Streamworks. So over here on the left for you guys, we've got the home screen for Novell Pulse. And on the far left-hand side of that, you're going to see our navigation panel. That's basically all the people and groups that you're following. So this is other Pulse users and groups that are in the system. You build those up, and then on the right-hand side, that's basically an aggregation of all the communications, all the waves that you've had with those individuals, and things that they've posted to their feeds for the public consumption or direct communication that you've had with them. So Dan, if you jump into Wave real quick,
sure,
we can actually send a message from Wave today, and it should appear, assuming that our network traffic works well, almost instantaneously over on Pulse.
And which was the user you wanted me to send it to?
K. Childs, I believe we are. Carl Childs.
Add him to my contacts. Go ahead and throw him on the Wave. And so what's going on now is similar to what Jochen's architecture earlier, the add participant operation should be being sent from the local wavelet here over there, but not quite. Are you K. Childs?
I am, and we're not having troubles. Let's see. Let's try this again real quick. Sorry about that.
No worries. Should we create a new wave?
Okay, so
there she is.
little delay there. But anyways, that's the message that Dan did. Yeah, thank you. All right, and so in Pulse, we can immediately come in here and start replying. So we can say, hi, Dan, how's the conference? And hopefully much quicker this time, he should see it over there. Oh man, we are just dying with this network, huh? There we go. All
There
right,
we go.
so like magic.
Much better.
Shows
much better.
up. So that's great, and it helps break down the barriers between the two projects. You can have people in Wave that you communicate, or any Wave server that you guys develop in the future. It should all just work that simply.
So my responses are going in over there? And
Yes,
then, yeah.
and right reply. So now, actually, we can also do the real-time editing as well. So if I go over here in Pulse and click Edit, I can go ahead and say, it's going great. And hopefully, over in Wave, in not too long, we should see that come across. OK, well, that's a good start.
Woohoo!
It's like we're running on a 28.8 modem here.
So I'd mentioned before advances in broadband technology. They are out there, I promise.
Yeah. So at some point that would come across, and basically Dan should be able to do the same, and we would see it over on the left-hand side. Well,
I think this wave may have gotten turbulent along the way.
OK.
Perhaps.
So we can try something really dangerous right now, which is
I suppose, I mean, they're all there. They'd like to see it, so we
Yeah.
probably should give it a shot, yeah?
So Dan told me a few days back, he said, hey, Novell's going to be on stage 2. That's all right? Everything's great. And I said, yeah, that's awesome. And then I was talking to Joseph and said, hey, why don't we try a three-way wave? So we're going to just be a little bit crazy, and I'm going to start an activity off. We're going to invite the guys, and we're going to see if we can get this to work. And now, our probabilities of success with the network could be crazy, but let's just.
But I mean, the whole point here is that it's many wave providers, not just 2 or 2. So let's give it a shot.
Okay. Okay, there's something crazy. Okay. I just got to invite you guys. That's right. So I'm going to invite you guys. Okay, Childs. And Dan. Okay.
So I got it over here on Wave Sandbox.
And if we head back to the home screen,
All right.
hopefully we'll see it there as well. Hey, it's
we go.
working better.
Indeed. So visiting the Wave Impulse.
Now I believe.
Yep. So we're typing a reply right here in Pulse, making
now-
a new blip.
Pumped over there. So
Yeah,
that's part
all
1.
right.
And now over there.
Okay, no, you're going to edit that.
I'm going to edit this.
So I can see it on mine.
And maybe.
Oh,
We'd be asking too much to see it over here, but we'll just. Yep.
There we go. A little more delayed than we would like, but it's getting there.
Next, last crazy thing. Let's see if we can get these gadgets working.
I mean, we got text. Let's do gadgets.
There's option 1.
There we go.
Sweet. Okay, so
And pulse.
and pulse.
All 3.
So we can go in and add some things, but I think we're getting to the.
I think we're getting kind of nitty-gritty here,
Yes.
but I mean, it's great to see a gadget added from SAP Streamwork show up both on Pulse and on Wave Sandbox, and that's sort of the overall direction of where we're headed here. I mean, I thank you all for your time listening to this listening to the presentation, various demos, and some of the quirks involved. But we're working really hard to sort of build this community, get more wave providers involved, get more use cases about how the protocol can work. Lots of specs and lots of code coming up on waveprotocol.org momentarily, and have some time for questions now at the end if people have them. We'll also jump over to moderator JD and Jochen. You guys want to come back up? Questions at the mics, if there are any? Yeah, please.
Within your demos where you're
Can you
doing
bring up
federation
moderator?
between,
Bring up the link, please.
in your demos when you're doing this testing between federated servers, have you had enough time to understand programmatically what latency is required as you add additional Wave servers to values of n?
In short, probably no. We haven't done extensive testing. The whole way in which the client-server protocol is designed is so that it is able to cope with latencies, disconnects, and all it really means is clients will optimistically modify waves locally, and the wave servers sync up in the back, and basically what you'll see is what you just saw. The experience degrades, but it should all function. It just means that things trickle in, and you guys might have experienced the bad network connectivity we have found ourselves, and yeah, if you can federate under conditions like this, I think you're doing pretty well.
Please, yeah.
I was wondering, I see on the Novell Pulse, I see an insert attachment. Now, I know we can't, one of the things that says wasn't done yet was federated attachments. Yeah. What about the attachments for just for Novell Pulse, just for Novell Pulse users? Does that mean that it can't be federated across, or it is not in the open source client yet for having attachments?
Well, I'm sure it works in Pulse, but it doesn't federate at this point, and the open source client does not do attachments as of yet.
Yeah, but we're
okay.
certainly working together.
Yeah, it will come.
Like in a dollhouse.
They're working together on that as well.
But I mean, you implemented a way to do attachments for just Novell Pulse.
Yeah, we did. So we have attachment support today. And the idea is that we're going to kind of, we have a kind of federation gateway that sits inside of our project, and we will, do the translation so that when the federation attachment, protocol is all worked out, we'll be streaming those across and receiving them back and all that fun stuff. Okay?
Okay, thanks.
Yeah.
Hi. As we've seen, it's sometimes quite difficult to determine whether the person that you're federating with is actually receiving the updates that you're sending to them. So you've mentioned that there's going to be a guaranteed delivery kind of part of the protocol. So will that include a mechanism to determine that I'm working on, as a provider, I'm working with my clients, and this guy that I'm working with is not receiving the messages?
Yeah. So we have an acknowledgement mechanism already in the protocol, and that should be sufficient to be able to do the retransmits from both the Fed1 or the production wave servers. That's the only bit that's really missing. Some of the error handling in the Fed1 wave server is also not quite complete, and that's the part that's kind of missing. Once that's done, it should be all good. You should already be able to determine on the wire what is and what is not arriving. It's just the retransmission that isn't working. All of this is pretty much already part of the spec. It's just not well implemented and is not thoroughly documented, unfortunately, but it's coming.
Let me grab one question from moderator, just because people were putting some questions into the Wave. So the highest voting question appears to be, will we be able to use the current Google Wave user interface with our private Wave servers? And so this gets back into the effort around open sourcing, which is what we're working on very hard around open sourcing the editor with a simple web client around it. And that's sort of beginnings of more client code. So getting the Fed1 prototype out there in the first stage was most important to be able to bring up more federated providers. And then moving on from sort of the back-end code to getting the model out there lets us be able to open source some of the client. And so that's what we're starting with today, and then more client will come as time moves on. So I think, yeah, please. Oh, thank you.
So what happens when you have two clients that don't implement the same
Operational transform?
No, I had it and I forgot.
Sorry.
The same, gadgets, thank you.
Sorry.
When you have two clients, and like two different clients on two different servers that don't implement the same gadgets, same like front-end plugins?
So I think you're saying.
I have a wave. I'm sharing a wave with somebody, and then I create a chart, for example, or something like that, and then that's not implemented on another client.
Well, so the way the gadget functionality works actually is so long as the wave provider supports gadgets, it should be the same set of APIs that are available. And so by putting it into the wave document is updated to have this link to the XML file that defines the gadget. And then it could be rendered on both sides.
Okay.
Yeah?
Yes.
For instance,
Yeah.
You saw we used the pro-con there, and our goal is so that any gadgets that come through from a wave, because they're gadgets, we want them to work in Streamwork, and that's kind of one of the reasons why we want to do this, is so that we can take a lot of the tooling that and different gadgets that come and bring them into our environment, and then they move seamlessly back and forth. That's kind of one of the goals that we're hoping to, and that we would inherit that by
Yeah,
working
so
with gadgets better.
we're building along a lot of the work from OpenSocial here with infrastructure like Apache Shindig, which lets people get their own gadget server up and running. And so as long as we all have a gadget server, it doesn't have to be Shindig, but as long as we have something that supports that OpenSocial gadget specification, then it'll all just work. Yeah. I wanted to grab, sorry, please go ahead. Yeah.
Well, you have a pre-configured version, so I can just take it and almost instantly implement it on my web server or my web page.
Sorry, I didn't quite catch the question. Maybe, Jochen?
So I think, so did you ask whether you can take the code that we are about to release and run it on your web server?
Basically.
Yes.
Pretty much. I'm not sure about how you'd hook it into your web server, but it runs with Jetty, and yeah, you can take it and put it up on your site.
I mean, you can definitely, if you have shared hosting or something like that, you'll be able to run it there. You'll need certificates and so on if you want to federate with Google Wave or with Streamwork or Pulse. But if you're not interested in federating, why you'd want not federate, I don't know. But you can just run it on shared hosting, and it'll serve an interface, and you can just use it directly through that with other people that you work with and so on.
Speaking about the federation crypto piece of it, Jochen, do you want to speak a little bit to why that's baked into the protocol?
I was going to pick up on the certificates that you mentioned. So as I explained, deltas are signed. For that, you need certificates issued by some well-known CA, certificate authority, and you need DNS records set up for the XMPP side of the federation protocol. It's a little bit of a hoop to jump through, but it allows you to use a secure federation protocol, which will federate with all wave servers that support it. And once you've got that, you're all good.
And the point there is for verification, and so you can't spoof and...
Yeah, so those are the security features of the federation protocol.
And so you know where the traffic came from. It's all signed.
Having said that, when you're testing locally, you can disable these actually, in the startup script, there's 2 flags. You disable it, you don't need any certs, you can use self-signed certs, but that'll only work for your own test rig. It won't work against Wave Sandbox or anything.
Yeah, so just for easier prototyping.
That's right.
Yeah. Do you have another question?
No, that's it.
Oh, okay. If there are no more questions, we'll be hanging out up front here, and happy to ask questions or answer questions one-on-one. Maybe ask a couple in response, but we'll see what happens. So thank you again for coming.